most exciting part of class is the camera setup. Hopefully not too many of you agree with that. So that's there. Okay, I like it. Let's do it there. Okay. All right. So stem and leaf, what the hell is that? Okay, so I love the name stem and leaf. Here's what it means. It's a very quick way to organize your data, yeah?
I don't think I have this picture.
Oh, really? Okay. You can have this one. I did write on this, but all right, so stem and leaf. The first part of chapter 2 is really all about how do I display my data for people, right? So we talked about histograms, bar graphs. Here's a stem and leaf plot. So what the hell is a stem and leaf? So let's do a very simple set of data. Let me see. Okay. So very often we're just going to make up some data on the spot. Okay, there's some data, right? So what a stem and leaf does is it takes the first digit of the number, very often, doesn't have to be, and after it, it just writes the second digit. So what do I mean? Aren't there numbers that are in the 10s, 20s, 30s, 40s, 50s, right? Those are the stem. I'm sorry, those are the stems, and then coming off of those are the leaves. So what comes off of 1? 1, 4, 9, right? I mean, you know, that's beautiful. That's pretty simple, right? So 2 would be 1, 2. 3 would be 5, 7. 4 would just be 0. And 5 would be 1, 2, 4, 7. Pretty simple, right? You with me? That's all there is to it. Now there are a couple little things you gotta be careful with the data that they give us. So I'll show you a couple more examples. That's basically it. There is one thing that if you don't include it, you will lose points. And I really want it to make sense why. If I just give this to somebody, this could mean 1.1, 1.4. This could mean 1100, 1400, 1900. It could mean a lot of things. I have to give them a key. I have to tell them how to read this thing. So can somebody tell me, what does this mean? That means 11. So now they know how to read the whole thing. If I just give them one example, they can read the whole damn thing. Because what I want you guys to realize is, everybody got that? Got that copy down? I'm going to do one thing to this. Don't worry about trying to copy this down. I just want you to get the idea. My original data could have been 3. 1.1, 1.4, 1.9, 1.9, 2.1, ba. This would stay the same. This would change, right? So now it means 1.1, 1.4. Do you guys get that idea? Yes.
Alright, so what if there's like no 30s up there? Do you
Oh,
still
good.
put 3?
Yeah, you put 3 and it would just be empty.
Okay.
And the reason you do that, if you guys just do this, doesn't that look like a histogram?
Yeah.
Right? Like that, that, right? You guys with me? You don't have to draw the bars. Don't draw the bars. But it is a quick visual showing you kind of like where things fall, how many things fall where. So if you have an empty class, don't just skip 3. Put a 3 and have nothing next to it.
Adding to that, so there's 1, 2, 3, 4, 5. So will we just go to the lowest to the highest?
Yes, good. So if it started at 70, you wouldn't put 1, 2, 3, 4, 5, 6, 7. You would just start 7, 8, 9, yeah. But anything in the middle that's empty, you got to represent that. So you got to actually show an empty spot. Now is that Difficult? That kicks so much ass, right? All right. Okay. So, there's really not that much more to it. So let's take a look at this. Can you guys do number 2 for me real quick? And the nice thing is, do you see how this is a beautiful way to sort your data by hand? You put 1, and then next to it you put, everything comes after 1, and you can put it in order if you want to. So if you really want to, you can put the data into a list and sort it, but you really don't have to, right? So try to do number 2 here.
Quick question. Those numbers that are on the graph, how did we get those again?
So you see how so take the little dots out, right? So it was 11, 14, 19, so forth. So aren't there some in the 10s, 20s, 30s, 40s? So the stem is just kind of like the main thing is in the 10s and the 20s, and the leaves are the specific.
Okay, now it makes more sense.
Yeah.
Okay.
So here, what's the lowest
The lowest number?
range? It's
It's
gonna be
12.
the 10s, right?
Yeah, yeah.
So you put 1, 2, 3, 4, and then what's the highest set of numbers? They're all in the 50s. So 1, 2, 3, 4, 5.
Okay.
And then after the 1, you just put the digit that comes after 1 each time.
Okay, now it makes more
Yeah,
sense.
yeah,
Thank
yeah.
you.
Alright, so hopefully everybody got the stems, 1 through 5, so it's 10s, 20s, 30s, 40s, 50s. And now, as you go, you don't have to, but it's sort of convention to put them in order as you go. So the ones I see 12 and 13, right? And 16, there you go. So it'll be 2, 3, 6. What do you guys see after the 2s? Any 2s? Nothing, so you just leave it empty. But that doesn't mean skip 2, you gotta represent it so it can show an empty spot there. What about after the 3s, what do we got?
3, 1.
Yeah, we got 1, 2, 2, right? 1, 2, 2,
3, 5, 7.
3, 5, 7, 11.
8.
Is there a 38?
Mhm.
There it is, thank you. Oh, Jeff, dude, let's try that again. 1, 2, 2, 3, 5, 7, 8, okay. What about 40s?
Just 2 1s.
2 1s, oh yeah. Dadgummit. So 40s,
No, 40s is 2 1s.
No.
40s 2 1s, okay.
You did great.
1 1, I'm doing fantastic.
5, 6.
5 6,
That's it.
okay. And then 50s,
0, 2.
yeah, 0, 2. And you can always double check, count how many numbers you got down there and make sure it's the same as the number of data points. I like it. Okay. What am I missing?
2. Key.
Key. What am I missing?
In the row where it's just, the 2.
Yeah.
Yeah.
There's nothing here, right?
Yeah, because there's.
So be careful. If you put this, what are you saying is in the data?
There's a 20.
20. And there's no 20, so you just leave it empty. And that tells somebody looking at this, oh yeah, there was nobody in their 20s or whatever this data is, right? So I am missing a key, and the key you can write any way you want to, but I always just write the first one. So you can leave the key off, you'll lose some points. One time I had somebody do this, the key was this, and it just kept going. I mean, do you understand that defeats the purpose?
Yeah.
Right? Yeah. Just need one key. It's sort of like on a map, you just need one scale. You don't go, well, here's this and here's, oh my God, no, just give me one scale. All right. Not bad. So, let me let you guys think about number 3.
So we don't have to put it in order to include. We don't have.
Yeah, you don't have to,
Okay.
but you might as well, because very often this will be the first step in a problem, and then I'm going to ask you to make a frequency distribution, all this kind of stuff. So you want it in order so it's easier to count the stuff. Yeah. So like I said, you could put that into list 1 if you want to. Well, if you need a bar calculator, we can do it whenever, because we're going to need them later. But you don't have to. This one's kind of gross. Why is this one kind of gross?
That's
4.
what.
The only stems are what?
4 and 5.
4 and 5. So it seems like there should only be 2 rows. But what am I asking you to do?
4 rows.
Yeah. So I'm not going to say, don't say anything. I want you to think about what that might mean, right? Would it be silly to just have 2 big ass rows? Because what is this? What is the purpose of a stem and leaf? It's trying to make a visualization so that I can quickly see how things are spread out, right? So if I have one like this is cool. This is nice. See how the middle one is big, so I can kind of see it as a histogram if I look at it like this. If I just have 2 rows and they're both kind of full, that doesn't give me any idea about how it's spread out. So think about this. If I put, so for this problem, if I put 4, 5, that would be kind of silly. Just have 2 big ass rows. It's not going to give me enough information. It's not going to be high enough resolution. Right? You're not going to break it down far enough. Are you guys semi with me? Do you guys see the problem? It would be even worse if there was just 4s. You'd have 1 big ass row of all the numbers. Well, what good does that do? So, if I did write this, what does this first row actually mean? From what to what?
From 4.0 to 4.9.
4.0 to 4.9. You guys with me? And this would mean 5.0 to 5.9. Do we have to slice it like that? Can we slice it better? So if I do this, now this is what you would write, but let me write on the side. This is not what you would write. What do you think this one would mean? 4.0 up to 4.4. Right? 0, 1, 2, 3, 4. So there would be 5 things that can go there. What would this one mean? 4.5 to 4.9. 4.5, 4.6, 4.7, 4.8. So I cut it evenly. You guys kind of with me? And I'm getting better resolution on my data. I'm seeing better where things are sort of spread out. So what really sucks about this data is it very spread out. No. So I'm trying to like cut it finer because it's not very spread out. This other data, it was from the teens to the 50s. I don't have to cut it down. It's spread out already. Maybe. All right, so now have fun. Go for it. And again, if you want to borrow a calculator and have the calculator sort that, feel free. You're going to need one here in a bit anyway. No, you don't. Exactly. So it's just understood. If I see repeated stems, I understand it's being sliced in the middle of those. Yeah. Still need a key though.
They did.
I'm just saying, Joe, you still need a key for that.
Question.
Yeah.
So when it comes to this saying 4 rows, are the rows this way?
Yes.
Okay.
So it's always rows and columns.
Oh,
right?
okay, got it.
Yeah. So once you got the idea, this is pretty much busy work. So I'm never gonna give you a sample of 80 data points. You guys with me? That would just be silly, right? So you guys help me out, because I obviously have trouble doing this. Let's see, so we got 4.0 and another 4.0 somewhere, right?
Yes.
All right, so 2 zeros.
Number 2.
And then we got no 4 ones, right?
No 4 1.
So we got a 4-2,
1 4 2.
no 4 threes, right?
Yeah.
Oh, is there?
Nope.
Nope. What about 4-4?
Nope.
Nope. But we do have a 4-5, 2 of them, right?
Yeah.
Okay.
On the next row.
Oh yeah, that's right, thank you. I forgot what we were doing. So yeah, you can have this sitting there if you need to remind yourself. And then I think we have a 4-6.
1 4 6. Yeah.
No
2 8.
4-7, there's 2 4-8s, right?
Yeah. 1 4 9.
And then a 4.9. Okay, so that's the 4s. So that's much better than just one big ass 4 bar and one big ass 5 bar. I'm getting much better resolution in my data. 5s, let's see, what do we got?
2 0.
2 zeros, yeah.
2.
And then 2 ones. And then a 2
1 2.
and 2 3s, right?
3 4s.
And then, what was it?
3 4s.
3 4s, yep, okay. And then switch down. At least 1 5.
Yeah.
So there's 1 5, right?
No 6.
1 6?
No 6.
1 6?
No 6.
No 6. 1 7.
1 7
And an 8. Alright. So now you can see it's concentrated in the middle. There's fewer on the outside. You could say this is really roughly normal. But you wouldn't have gotten this idea if you would have just had 2 big ass rows of numbers. You want to break it down further. Alright. How do you guys feel about that? So excited, I know. Okay. At least it's not crazy hard. It's pretty straightforward. I'm not necessarily gonna give you this kind of problem, but I just want you to understand there is this flexibility with the stem and leaf. Okay. Yes.
So for the 4s, like 4.0 to 4.4, 4.5 to 4.9, how would we do 5? So just do the same thing?
Same thing, yeah. So this would be 5.0 to 5.4, 5.5 to 5.9.
Okay.
Because you want to cut them exactly in half.
Oh, make sure
So
they're
0
the
to
same.
4, 5 to 9.
Okay.
Which is why our rounding rules, 0 to 4 you keep it, 5 to 9 you throw it up, because then it's cut evenly. It's cut right in half, yeah. Okay. Alright. Not too bad, right? That's kind of nice compared to some other stuff we've done. Okay. So now we're going to get into some more pure math stuff. Right? In this math class, we're going to do some math. Okay. So, tell me this, have any of you guys taken the, I think they still do, the SAT or the ACT? You guys taken that? When you get your results, I'm curious if they still do this.
They give you percentiles?
They give you percentiles, right? So they'll tell you, you were in the 87th percentile or whatever, okay? One reason they do that is the SAT, the same test each time they give it. No, of course not, right? Because then it would be easier to cheat, right? You could just take a copy and your friend would go the next weekend and they already know all the questions. You guys kind of with me? So they have to change the test every time. Now stay with me. Could they randomly change it so that it gets a little harder than it was before? You guys agree with me? If I change a test, couldn't I accidentally kind of make it a little harder than it was before? What percentiles do is they try to keep your performance relative to everybody else. So if I make a little bit harder SAT test and you make a lower score, you could still do relatively as well as somebody who took the easier SAT test and made a better score. Right? So let me give you a little, my first class in grad school, took the first test, the teacher gave it back, I got like a 19 out of 40. Was my grade, right? Which is not good, yes? And then he came back by, he's like, good job, Jeff. And I'm like, what is happening? Because when he gave me my test, I'm like, am I supposed to be here? Was this a good idea? I started questioning all my life choices, right? What the shit am I doing here? And he's like, good job, Jeff. And I found out the average was like a 12 out of 40 or something insane, right? So I realized it was a physics program. I realized they just make their tests hard as shit and then they curve the hell out of it, right? So the score 19 out of 40 is bad. But relative to the class, it was good. You guys understand? So if somebody's in a totally different stats class and they say, I got an 80 and you got a 79, I did better than you, is that really necessarily true? What if their average was a 90 and your average score was a 50? You did better when you got that 79 than they did. You get relative to the class. Are you guys with me? So that's one reason we use percentiles, is because then it's more fair to compare. So what the hell does a percentile mean? So let's say you took the SAT and you got in the 87th percentile in math. What does that mean? Did you actually make an 87 on the test? What does that mean?
87% of scores were lower than yours.
Yes, so percentiles in general mean that percentage scored below you. So what percentage of the people who took that test scored better than you? 13%. Does that make sense? So that's relative to everybody else, right? I think maybe it's the ACT that does this, but I can't remember. So this would mean that 87% of everyone else scored below you. It doesn't mean you made it 87. So my 19 out of 40, what is that roughly? It's
19 out of 40.
10,
It's
50 is like 48% or something.
48.
So I made a 48. But relatively that was a really good grade. You guys understand? And of course he curved it, so it was whatever it was. So maybe I got in the 87th percentile. Maybe 87% of the other people scored below me. Now, you guys get a feel for that? So if you ran a race and your speed was in the 60th percentile, what does that mean? 60% of everybody else in the race were slower than you, right? So is it good to have a higher percentile when I'm talking about speed in a race? Do you want a higher percentile if I'm talking about speed in a race? Yes, you want more people to be slower than you because that means you're going to freaking win the damn race, right? Yes? Stay with me, stay with me. What about time? What if I scored in the 60th percentile of time to finish the race?
That's bad.
That's bad, right? That means 60% of the people took less time than I did, yes? So if I'm talking about time it takes to finish a race, is a high percentile good? Shit, no. What about golf? Any of you guys play golf?
Once, just once.
I mean, not putt-putt, right? So, well, you played golf once?
Yeah.
Okay. I actually took golf class in high school, and it was really pathetic for me. So, golf is not in my genes. But in golf, do you want to have a high percentile for your score? No, because a lower score is better. So, do you understand what I mean? Percentiles always mean the same damn thing. That percentage of whatever was below you. Good or bad depends on what the situation is, right? Okay. Now, stay with me. I'm going to put up here a very small sample of data, and we're going to get a feel for how to do the math to calculate percentiles. You with me? It's a very small set of data, so I'm going to come back to that idea. So I'm going to make 10 data points. Let's see. Let's get 12. What's that so far? 10, 5, 6, 7, 8, 9, 10. Okay. So can somebody tell me what they think? Go ahead and copy that down, sorry. I want you to tell me your guess for what the 80th percentile is. And by the way, the notation for this, just a big old P with an 80 on it, right? P80. So if I see P11, that means 11th percentile, right? This is going to show up every now and again through the whole semester, this notation. So, does somebody have a guess for me as to what the 80th percentile might be? All right, so I got a guess of 35. Does everybody agree with that? Anybody disagree? Oh, okay, I got a guess of, what would say?
42.
42?
So you say like anything above 31.
All right.
I was thinking
Say again?
anything above 31.
Anything above 31.
Yeah.
So, all right. So we got some disagreements, right? Yes.
Oh,
Does 80 percentile mean 80% or worse, or does it mean 20% or better?
Both. Which actually leads to the answer. So, there's 10 numbers, correct? Stay with me now. There's 10 numbers. 80th percentile means it's the number that's above 80% of the data, correct? What's 80% of 10? 8. So if you think it's 1, 2, 3, 4, 5, 6, 7, 8, there's some evidence for that. Actually, it'll be this one. Doesn't this one have 8 numbers below it?
Yeah.
Yeah. There's nobody suggested that one was sorted, did it? Now, 80th percentile, if there's 80% below it, what percentage should be above it?
20%.
20%. So then you think the answer would be this, right? So you sort of kind of like bouncing around a little bit. There is a number. It's not one of the data points. There is a number that has 80% below it and 20% above it, which means 8 points below it, 2 points above it. And it's the number that's right in the middle of those two.
So 37 and a half.
37 and a half. I really want that to make nothing but sense, right? 37.5 has 80% of the data below it and 20% above it. Is that cool? Okay, I like it. So in this case, the sample was so small that the actual percentile answer was not one of the data points. Doesn't have to be, especially when the sample gets smaller and smaller, there's fewer numbers that it could be. Maybe. So I really want you to understand, what was the very first thing we did, and the very first thing you guys did to get a feel for the guess? What did you do with this? 80%. You took 80% of something.
The number.
Yes, you took 80% of 10, right? Just to kind of get in the right general area. And I appreciate that a lot of you guys were like, oh, I got to adjust that a little bit. So if I had 27 numbers and I want the 80th percentile, I would take 80% of 27, right? So the variable we use for sample size kind of makes sense. It's n, the number of, right? So the letter n means the number of things in your sample. I really want this to make sense. So please make this, if I have 1,000 numbers and I want to know the 80th percentile, don't I need to go 80% of the way into the list? 80% of 1,000, right? That's the first step. But the second step, because was the answer the 8th number? Was our answer the 8th number? No. Okay, so stay with me. This is kind of cool. There's only 2 possibilities for percentiles. Either you do this work and it comes out to be a whole number. And if it comes out to be a whole number, you average this with the next one. So we took the 8th number and averaged it with the 9th number, and that's what we got. All right, so let's try this. What is the, what is P42?
42nd percentile.
42nd percentile. So there's 2 steps to figuring this out. I want the 42nd percentile. So what's the very first step to figure out where the answer is going to be? I take 40% of 10. What is 42% of 10? 4.2. It's really nice when you do percentages of multiples of 10, right? And again, if you don't know, you just do 0.42 times 10, right? If you get a whole number, you average that with the next one. If you get anything else, you round up and take that number. So I round up the 5, so the 5th number is the answer. What's the 5th number? 25, yeah. Crazy sauce. So I really want this to make nothing but sense. If I had a list of 287 data points, right? And I want to know the 12th percentile. I want to go 12% of the way into the list. 12% of 287. That's always my first step. If the answer is a whole number, you average it with the next one. If it's anything else, you round it up and take that number, right? So there's always 2 steps to percentiles. Where is the answer? Go get the answer, right? Okay, I like it. So what I want you guys to do right now, I want you to use the same data, and I want you to figure out 3 things. I want to know what P25 is, P50, and P75. People next door are excited about this. I don't know if you heard them. If you need to borrow a calculator, they are just sitting right here for you, right? I haven't done it really yet, but this should be quick to check. Yeah, so what'd you get? Bam, bam, bam. Yeah, the middle, let's see. Yeah, these 2 should be decimals, and this one should come out to be a whole number that you have to average, so it looks like you get that idea. Yeah, and the funny thing is, when it's a small set of data, you actually physically cut in half. You cut each half in half, right? But when you get a bigger set of data, it's a little bit harder to do visually, yeah.
Maybe if it's like organized into like rows, but like tabs.
Yeah, you could, yeah. You could totally set it up so you can attack it, but I still need to see some idea of work all the time, right? So, yeah.
We'll not do this on an actual census.
Well, if you showed me half and then half of half, I could live with that. Right? By the way, I wrote the data in a very specific way that made this possible. In order. Do you understand? If the data was not in order, you first need to put it in order for this to make sense. Because otherwise, I can just put it whatever order I want to and make these answers anything I want them to be. So it has to be in order for this to work. So, what did you guys do for the P25? Yeah.
25% of 10.
25% of 10?
And then
2.5. That's a decimal, so
I round it up.
round it up to the 3rd.
The third number is the answer. So what's the third number? Put this down here. Yeah. 1, 2, 3. So the second step, go get it. Like this. Kick ass. By the way, if you're 25% of the way through a football game or a basketball game or something, what do we call that? The first quarter, right? So the other name for P25, good Lord, is Q1. First quarter. So what's P50 otherwise known as? Q2. And that's crazy enough, Q3, that's crazy. So we can break percentiles are broken down very specifically 1, 2, 3, 4%, right? Quarters are 1, 2, 3. First quarter, second quarter, third quarter. And then you got beginning and end, otherwise known as low and high, right? So we'll come back to that in a minute. How do I do P50? Well, the first step would be
50%.
50% of 10, which of course is
5.
5. And getting a whole number sort of sucks because it's more work. How do I get the answer?
Between 5 and 6.
Between the 5th and the 6th. Got to average those. 1, 2, 3, 4, 5, 6. So those two averaged comes out to be 25.5. Kick ass. Right? So not horrible. It's pretty easy. One thing I really want you guys, I've said this already, but why do we keep putting 10 here?
Show how many.
Because there's 10 data points. If you have 80 data points, don't put 10 here. I have people do that because the first example I do is with 10. So they're like, it's always 10. No, it's however long your data list is.
Do we have to do Q2 or can we just do P?
Yeah, you can do P50, that's
Okay,
fine.
okay.
Yeah, I just wanted to put, you can see this either way.
Okay, cool.
So now watch this, it's kind of cool. I want you guys to get this. If 25% of the way in means count 3 in from the top, I really want this to make sense. 75% should be count 3 in from the bottom, right? I really want this to make sense. If I go 25% and now I want to go 75%, isn't that just 25% from the other side? So the shortcut would be 1, 2, 3. This should be 35. Let's double check. First step would be to take
75%.
75% of
10.
10, which of course is 7.5, so it means round up to 8. And the eighth number is 1, 2, 3, 4, 5, 6, 7, 8. Hey, 35. So once you get P25, it's completely cool to do the shortcut. Just count, I had to count 3 in from the top for P25. So if I count 3 in from the bottom, that's P75. Because they should be symmetric from each other. Right? Does that make any sense? Okay. Now let me do this. Has everybody got this? I'm going to kind of summarize what we got and do some more stuff with it. So we got, let me put this right. Q1 was 19. Q2, 25.5. Q3, 35. What's the lowest data point? 12. And the highest one was 42, which is the answer to life, the universe, and everything. It's kind of funny, but this is called the 5-number summary. So if you see me ask you, calculate the 5-number summary, that means this: the start of the game, first quarter, second quarter, third quarter, end of the game, right? So this is called the 5-number summary, which I don't think people at home can see. People at home, oh, you can see it. Look at that. Yes. All right, so we're gonna make a visual out of this, and then I want you to tell me if you've ever seen this before. And by the way, I do this almost all the time. I'm gonna talk, right? You're like, God, this guy ever shut up? And then I'm gonna finally shut up and give you a worksheet and let you guys work. All right, so just hang out. If I wanted to make a scale so that I capture all these numbers, maybe I can start at 10, right? I want to capture all of them. And maybe I can go up to what? 45. Right, so maybe we can go by fives. So let's see, 10, 15, 20, 25, 30, 35, 40, 45, okay. Now, every data point has a place to go, yes? We're gonna do a little bit differently than algebra, right? Because we're better than algebra, we're above algebra, right? We're gonna put, instead of a little point like you used to do on the number line, we're gonna do something weird. Above each one of these, I'm gonna put a line. So like above 12, I'm gonna put a line. Keep going. Above 19, let's put a line. Above 25.5, put a line. 35, put a line. 42, put a line. I made some pretty symmetric stuff. All right, and that's just weird, yes? So what I want you to do is the middle three, connect them in a box. And then the outer ones will be what we call the whiskers. Yes, this is a box and whisker plot. Yes, stats people are weird. That is a box and whisker plot. So if I ask you to create a box and whisker plot, this is what I mean. Somebody remind me, what was that line?
12.
No, I mean, what did it represent?
Oh, 11.
The lowest, Q1, Q2, Q3 high, right? 5-number summary, visualized. So let's say this is scores on a quiz for one class. What if the other class looks like this? Which class do you think, would you say, did better overall on the quiz? It's kind of a judgment call, really. Yes?
I'd say the bottom class.
Yeah. Can anybody tell me? See, I think some of you guys got to get the reference. What's in the box? What percentage is in the box? I don't care what it looks like. This is such a weird question, right? You're like, oh, what's this, a magic trick? I don't understand.
75%.
No.
50% of the
Maybe. So, what is this again? Low, Q1, Q2, Q3. Stay with me now. What does Q3 mean? What's it also mean? P?
I guess you said
75. What does 75th percentile mean? What percentage is below it?
75%.
Now, stay with me, stay with me. 75% is below Q3, yes?
Yes.
What's this side of the box?
25.
Q1. P25, so what percentage is below it?
25.
25%. So what percentage is just in here? You chop 25% off and you get 50%. So anytime we see a box and whisker plot, we see these sometimes as outliers, possibly. And the heart of your data is the middle 50%.
So anytime we say box, no matter what, it's 50%?
Yes.
Okay.
Yes. So if I saw another class that looked like this, same scale, right? These have the same scale. I just don't want to write them again. This one should be pretty obvious. Actually, let me do this. Why does that one look weird?
Because there's no high. Because
There
the
is a high.
The high is the same as the Q3.
Yeah, if Q3 is equal to the high, that's how it would look. You guys with me? Like you would draw a line for Q3 and then you would draw a line for the high. And the way the book does it is they make it a dashed line. That means there's two things like right on top of each other. Are you guys semi with me? So you can have repeats. You can totally have repeats. If there's a lot of repeats in your data, you can have repeats here, right? Now, obviously, which class did better? 1, 2, or 3? 3 did better. I mean, 50% of the people got these kick-ass grades, and then there's one guy down here. Oh shit. Or maybe there's more people. You just don't know. Well, what percent of the people scored in here?
25.
25%. Is that cool? Because that's the low, and that's Q1. So do you guys see how to dissect this kind of visualization pretty quickly? Maybe? Okay, the box is definitely 50, but in between two successive lines, there's always 25% of the data.
So the box, here's the box on line 3, to the left
is 25%.
From here
Yes.
down, there's 25% of the students in
And
here.
then to the right, it's 75% up.
Yeah, so 75% of the students are here.
Okay.
So it's very obvious that these guys did better than these guys. Right. This could be a little bit strange. Well, no, you can do this. Which one of these do you think has the grades that are least spread out?
Second one, yeah. The second one.
The one thing about, so, okay, this is a little bit weird of a question because do you see how far these are? And the boxes are almost the same size. So it's kind of a, I would think it'd be this guy, but we're getting close to the point where not only do we want to know general things about the data, we want to know how spread out the data is. Would you rather see a list of 800 data points and just stare at it? Or would you rather have somebody give you one number that represents how spread out the data is? I'd rather have one number that represents how spread out the data is, right? So we're working in that direction. Okay. All right, so these are box and whisker plots. They come from the 5-number summary. So now I will shut the hell up and I'm gonna let you guys work on something. Anytime, Dana. So the side that says percentiles and box plots. Yeah. That's the side I want you to work on. Let's see if anybody comes up. Anybody need to borrow?